In our last example, we're supposed to write an equation in slope-intercept form of a line that passes through negative 4, 6, and is perpendicular to the graph of 2x plus 3y equals 12. Well, I think what we'll do first off, we've got to figure out the slope of our line. So I'm going to take 2x plus 3y equals 12. Well, how do you find the slope of a line given in standard form? There's two ways to do it. I could find 2 points and then use my slope formula to find that. Or I could just get y by itself. I think that's what I'm going to do. I'm going to get y by itself. So what I'm going to do first off, I'm going to subtract 2x from both sides. So then I bring down my 3y, because the x's cancel, equals negative 2x plus 12. Then I'm going to divide everything by 3. So y equals negative 2/3 x plus 4. I really don't care about the 4. What I'm interested in is the slope. So the slope of this line is negative 2/3. So the slope of a line that's perpendicular to it would be positive 3 over 2. Now I'm going to use that to write my equation of my line. I know it goes through negative 4, 6. And just like the last question, I'm given a point and a slope, so I think I'll start this with point-slope form, and then I'll convert it to slope-intercept form. So I'll say y minus y1 equals m times x minus x1. Or y minus 6 equals 3 over 2 times x minus a negative 4, which I'll say is x plus 4. Now we want to get y by itself. So I'm going to distribute my 3/2 inside the parentheses. So we get y minus 6 equals 3 over 2x plus 2 goes into 4 twice, and 2 times 3 is 6. And then to get y by itself, we're going to add 6 to both sides. So then we get y equals 3/2 x plus 12. And there is your equation of your line in slope-intercept form. And that's all we have to do for that one. So just as a review, to sum it up, parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Sometimes we call them negative reciprocals, but opposite reciprocals. Or they multiply to -1. That's what the graphic says. But I just like to remember opposite reciprocal.